Reflection, you'll remember, is an isometric transformation, so it doesn't change the size or shape, but it just changes its orientation. So the image of point A is reflected as A, and we can call that A dash, or you would have remembered last year we called it A prime, so either one is correct. So each reflected point is reflected on the other side and is notated with that little dash mark. Lines of symmetry are mirror lines. So if you can draw a mirror line here, I can fold this side onto that side, and they match up absolutely equally. So a square has a whole bunch of them, because if I fold this triangle over, it will still match absolutely equally. So a square has 4 lines of symmetry. So we're going to copy and draw the reflected image over the given mirror line. So this is our mirror line here. So each of these points is going to be reflected on the other side of the mirror line. So this is the best way to do it. Here we go. So we're just going to have to guesstimate sort of how far away we are. So let's start with B. So if we draw a line here at a right angle, we draw the same distance at our best guess, and you got it, we're going to call that B prime. Now A is along that same line, but it's a little bit further out, so let's guess about here for A, and because it's the reflection, it's A prime. Now how far is C from that mirror line? We'll guesstimate the same amount, about there, and that's going to be C prime or dash. And again, how far is D at right angles? Looks like it lines up pretty much with C, so D prime will do the same, and it looks like E prime lines up pretty well with A. So here's our reflection, and then all we have to do is join them up, and we've got our best guess at the reflected image. Now this one is a little bit different because this line is on an angle, but the principle is still the same. So point A is right on the mirror line, so we can just go ahead and call that A prime. Point B at right angles is going to be out here, the same distance, and so point B is reflected as B prime here. And point C, at a right angle to the mirror line, going the other way, is about there, shall we say, and that's C prime. So to get the reflected image, we connect each of these points, and we get our best guess at a reflected image. And notice that it crosses over, and that's okie dokie finoki. There's no problem there. Now when you go to actually coordinates, it's actually a little bit more exact, and it's nice. So we're going to first reflect each of these on the x-axis. So this will be our mirror line, kind of like looking at a still pond or lake and seeing the image reflected. And then on the y-axis, which is this one here. So kind of like looking into a mirror standing upright. So reflecting this on the x-axis. So if this is our mirror line, then A is on the line, so it's going to stay A prime. B is 3 units away, so we're going to put B prime down here. And C is 2 units away. Much easier when you can actually count them out. And C prime is here. So connecting the dots, we've got the reflected image on the lake here on the x-axis. And this also acts to state the coordinates of this. So for this one, we've now got A prime on the x-axis at 1 on the x and 0 on the y. And we've got B prime at, what is it on the x? It's 2, still positive 2 there, but negative 3. And if we look at C prime, then we have that at 4 on the x-axis across, and up and down it's negative 2. And what's interesting there is that each of the original points are just the opposite on the y only. The x is the same. So A is still the same, 1 on the x and 0 on the y, because it hasn't moved. But B has gone from positive 3 on the y to negative 3. Isn't that interesting? And C has done the same. It's gone from positive 2 on the y-axis to negative 2, which is really cool. So that's the way you can check you got it right. And if we're going to then reflect this on the y-axis, then we're looking at our mirror line here. So we're standing up and looking into the mirror and seeing how gorgeous we look. So A, the new A prime over here, is going to be 1 away to the left. So our x is changing. B is going to be 2 points that way. I'm sorry, B prime. And C is 4 this way, so it's going to be 4 that way, and is over here, C prime. So connecting these dots, I get the same shape, the same size, but the image is reflected. So where are the coordinates according to the y-axis? You'll notice a similar thing. I'll write it here for comparison. So reflection on the y-axis, A prime is actually -1, and the x remains the same. Interesting. The B prime, when we're reflecting on the y-axis, becomes on x -2, where it was +2 before, and it's still +3 according to the original. And C prime, reflected on the y-axis, gives us on the x -4 and still +2. So the y doesn't change, but the x does. So I think that's enough for you to go on for now. Have a go, and have a go with the other one, and see how you go with the exercises.